All right. Our objective here is to solve quadratic equations by finding square roots, and also solve quadratic equations by finding square roots even when there are complex solutions. But before we do that, we're going to review section 5.2. So let's try a problem. So basically, all quadratic equations, squaring stuff, we can not a problem. We can basically square root both sides, but not really. Not really. What we learned to do in this case is to factor this side. So we're factoring it, and then we have two linear factors. And if the whole thing, this whole multiplication problem equals 0, then that means either this is 0 or this is 0. But what I want to point out is that factoring it is not that different than taking the square root of both sides. If I have a problem like this, x squared equals 36, I square root both sides, but really to square root it, I have to be able to factor it in that special way where it times itself equals this number. And then I can square root both sides, say x equals the square root of 36. So that's what we're going to start doing in a minute in section 5.3. Before we do that, though, I want to show one more complicated type of problem in section 5.2, where you have a coefficient in front. So I'm going to go ahead to do number 43 on page 260. Well, I'll do 40. Yes, it's 18 n squared plus 9n minus 14 equals 0. And, you know, before when we said, okay, my factors have to add to the middle term and multiply to the last term, that was because it was based on sort of doing FOIL in our heads backwards. We have to go a little further with the FOIL in our heads backwards now, because now, because of that 18, what goes where these arrows are is not just n and n, right? It has to be some combination of coefficients that multiply to 18. So it could be n and 18n. It could be 2n and 9n. It could be 3n and 6n. And then in the back, we still do have, that's the same, we're still going to have pairs of numbers that multiply to 14. So 1 and 14, 2 and 7. And so those are all pairs. I can't mix and match. Like I can't pair the 9 with the n, right? It's got to be the pairs that go with each other. So I take the pairs over here, and I try to see, basically I try to arrange double dates. So if I say this n and 18n, if I combine them with like the 2 and the 7, so I get n and 18n, will that add up to 9? Well, or subtract to 9, because really, but in my brain I just say, oh, add or subtract, so we'll get to 9. We'll get to 9 this way. So, and right off the bat, well, no, it won't, because 18 times 7, that's like 126, that's too big. So that's not it. So then I'm going to try, what if I move the 18 over here with the 2, and then I get 36 over there, 7 over there. There's no way 36 and 7 make 9. They make 29 maybe, but not 9. So that's not it. So then I'm going to try 9n and 2n. 9n, 2n. Okay, well that's 18 and that's 14. I'm getting closer, but no, that doesn't work. And I could switch the 9 and the 2, and then I get 63 over here, so that's not going to be it either. So, but I'm just trying different things. And I notice I have not even tried the 1 and the 14 yet. Maybe I should. The 9 and the 2. Put the 9 here, 9n here, 2n here, and so this is 9 and this is 28. Now 9 and 28, that doesn't work. All right, so trying a few more things. I got the 6 and the 3 to work with. So if I put the 6 here and the 3 here, and I get 12 and 21. 12 and 21 can make 9, right? I make the 12 negative and the 21 positive. So that's what I'm going to do. So this is 6n and 3n. So I'll have 6n here, 3n here. Now, of course, you'd think that the 2 would go here because it's circled, but that's not right. Because when I say that the 6 goes with the 2, I'm doing the outside-inside part of FOIL. So I don't multiply the number that's in parentheses with each other. So I multiply the 6, when I multiply the 6n when I do FOIL, I multiply it with that number over there. So when I say the 6 goes with the 2, I mean like that. And then the 3 goes with the 7, like this. Now I want my 21 to be positive, so the 7 is to be positive, and then my 9n is going to be negative. And that's how I factor this problem. And the rest of it is basically easy. 6n equals negative 7, so, because 6n plus 7 equals 0. Sorry, that's my first step. Subtract the 7 from both sides, so n equals negative 7, 6. Or over here, 3n minus 2 equals 0. So 3n equals 2. So n equals 2 over 3. I'm not saying it's easy, but that's one of them. And that's how I did it. And I'm going to move on to something else. But if you want to see more of these problems, in case you could email me and I could, or see me after school, like right now. It's between 3:30 and 4:30. I'm around. All right. So section 5.3 talks about solving quadratic equations with square roots. So we have problems like this. Just an easy one. X squared equals 64. Common mistake would be just to say, okay, x equals 8. That's wrong because x could also equal negative 8. So most quadratic equations have two solutions, positive and negative 8. So when you square root both sides of an equation, make sure you include your plus and minus. All right, so unfortunately they're not all perfect squares like this. When they're not perfect squares, we have to deal with something like this. X equals 30. Actually, let's say x equals 32. So x squared equals 32. All right, you with me? Good. Square root both sides, so x equals plus or minus root 32. All right. Why did I do this problem? Because we have to take out any perfect square factors. Why would we have to do that? That's annoying. I don't want to take out perfect square factors. Because if I leave it like this, that's that's a big number to take a square root of. If I punch it in my calculator and approximate it, then I'm approximating. I want to keep it. I don't want to approximate. I want to be exact. So I can't just take this out of there and say, oh, it's a little, it's 5.7, because that's an approximation. But I can make the square root more simple, because I know I can multiply this thing out, right? This is actually 4 times 8. And that also breaks down to 4 times 4 times 2. Well, so in other words, it breaks down to 16 times 2. Now, some people like to actually break their things down to something like this before they free it from the square root, but I don't usually. To me, this is easier to look at as 16 times 2. And notice that I can put the 16 and the 2 in the same radical, or I can put them in different radicals. It doesn't matter. They multiply freely. What I cannot do is take them out of the radical. I couldn't just say, oh, it's 16 root 2, because 16 does not equal the square root of 16. They're different, right? What's the square root of 16? It's 4. And so that is my answer. 4 square root 2. X equals that. Are you guys having fun? Haven't you missed videos? We should watch more videos. I should make more videos. Alright, so notice how, like I said, it doesn't matter. This could be square root 16. Square root 2 is the same as square root 16 times 2. So the multiplication can happen inside the radical or outside the radical, but they do multiply that way. Well, same thing with division. So I have a problem like this, number 48, page 267. I can change that to this. But now we come with another rule. So basically you got to realize if it's a radical, it's not standard form, and if it's not rational, cannot be simplified, it's an irrational number. And so now I've got two irrationals, one on top of the other. So somebody decided, well, when you that's two irrationals, it's too crazy, and we need to like simplify one of them. So it's an annoying thing to have to do, but luckily it's easy enough. Because to get rid of a radical, all you do is multiply it by itself. And you can't do that whenever you want to, but you can do it when it's in fraction form, because you can just multiply the top by the same thing. Alright, so 18 times 13, that's, equals square root. I'm going to change the 18 to 2 times 9 times, and then there's add the bring in the 13. And on the bottom, I just have 13, because look, square root of 13 squared is just 13. And that was the purpose. Now I have a stable denominator. On the top, I'm going to pull out the 9. Square root of 9 is 3. The 2 and the 13 make 26. So my answer is 3 root 26 over 13. Now, if there were any steps that seemed like they got skipped, well, basically what I did was square rooted the 9. So because it's a perfect square, I could take it out of the radical. Say the square root of 9 is 3. And then 2 times 13 equals 26. So that's where I got, there's the 2, there's the 13, so there's 26. And that stays in the radical. So that's the shortcut steps I took. Alright. This video is almost over. But I want to remind you now what the heck happens if you try to do this. Alright, now this is where it gets crazy, right? X squared equals negative 1. 1 squared equals negative 1. 1 squared does not equal negative 1, right? Negative 1 squared equals negative 1. No, negative 1 squared does not equal negative 1. It equals 1 also. There's nothing squared that equals negative 1. But what if there was? Well, if there was, we would call it I. So we created a whole number system based on this. I squared is negative 1. So it's almost like this weird, fun thing that mathematicians decided to do. Alright, so if I squared equals negative 1, then I equals I. What is it? It's the square, I equals the square root of negative 1. I squared equals negative 1. I cubed equals negative, these two things times each other, right? I times I squared, so I cubed equals negative the square root of negative 1. And I to the 4th equals 1. Mine, well,